In this video, we'll take a look at another method of communicating change over time. And so far, whenever we've looked at time, we've looked at it in this fashion where we've used an x-axis to show the progress of time, or time's arrow moving from historical time on the left to more towards the current period on the right. And there are other ways of demonstrating time. They're not always the most apparent, but in this case, we can probably answer some of our questions by changing up how we conceptualize our visualization of time. And so if we're still looking at this question about the increase of strikeouts over time and its relationship to pitchers per team, we can just basically start with a regular scatter plot. So I would select year. In fact, I'm going to even make a copy here of year, a duplicate, and I'm going to change this to a dimension. So I'm going to convert this to discrete. And we get the blue. So we now have a dimension, and we'll have our two measures of pitchers per team and strikeouts. So pitchers per team and strikeouts, and click the show me, and we can get our scatter plot up. Okay, so in this case, our pitchers per team are listed on the x-axis. Our strikeouts per game on average are listed on the y-axis, which means that the points here are actually the years. And so years now become these points that show the intersection of pitchers per team and strikeouts. And so we can make this visually a little bit better in a few ways. One, instead of automatic, I'll go to circles. And then I'll take the trend line. So let's take a look, and we can add our trend line, and it's linear, so we can do that. And we can even describe our trend line if we right click on it, describe our trend line. And we'll see here that our p-value is less than 0.0001, which means that we have a very close correlation, right? And so basically it also tells us here, right, it's got our coefficients. We can close that. And if we were to look at our R-square value here on the trend line, our R-square value shows 71%. So the variation in pitchers per team explains 71% of the variation in strikeouts. So it's a pretty close correlation, and there may be something to this as a causative factor. So there's a few other things we can do to communicate these data points. So we want to check order because time happens in an arrow. And so while that explains the variation, how has this happened over time? We want to visualize that. So the basic scatter plot doesn't show time's arrow, so we have to see if it does. So we could take year, go back to data, and we could take year, right? And we can add that to color. And so by taking year and adding it to color, we have a variant. So it goes from lighter is further in the past, darker is more towards the present. So we see that based on the shading, that time's arrow does in fact tend to follow this trend. With a few exceptions. There are a few exceptions where a later period has it falls before the line. But basically the circles in the lower region here, the lower left-hand region, those are earlier times. And in fact, you can even filter this. So if you wanted to filter it, create a little early sort here. So you can change the take the year, right? And you can put that in filter, and you have that. And I can edit out or just say I only want the current year, so I'll uncheck those and say everything since 1981, which was one of those big years we talked about. Okay, so we have that in the filter, and notice we see times arrow. Oh, that's an accidental click. So we can also take years, right? And we can add these to label. And I also don't want overlapping years, so I can go to label, right? If I clicked on that, that says allow labels to overlap other marks. I don't like that. So if I do that, it doesn't allow that to happen. I can also go here and I want bold so it stands out a little better. Okay. I can even increase the size if I wanted. So we get to see times arrow. We saw the filter or the sort. So some other ways we can take a look at this, right? So I would just make a new sheet here. And I take my columns, and I have pitchers per team in columns. And I have strikeouts in rows. And I move this to line. And I take year. And I move that to color. Path. I move that to path. And that is the rather interesting visualization I get. Now I want to make labels, so I take my year and I put labels. Okay, and then I can add my trend line back here, linear. So I have my trend line. Now I don't really like that. That's a rather interesting plot there. The pattern's very clear between 2007 and 2012. Strikeouts increased quite a bit, while pitchers per team really didn't. So we can see that. But we want to maybe make a few changes to make this a little more visually friendly. So I'll take a second pitchers per team pill from the data set and drag it onto the columns shelf here, over right next to here, and it'll then click here and make this a dual axis plot. And where it says up here, I right click in the top x-axis and I'll synchronize the axis, and I'll also uncheck the show header here because I've got the header down here. Okay, and if I take the all section and I take the measure names off of color so they're not there, and I change my mark type here for pitchers per team number 2, and I change this from line to circle. We'll see those points, and I want to change the circle's color, and I want to change it from blue to white. No, that's not what I wanted to change. So I'll click the undo button. So pictures number 2, circle, color, white. Okay, give it a border. I want a darker black border here. I could also go with a gray. Seems to be a little friendlier. And on labels, I don't want that. Okay, so I've done that. And now in the marks panel for pictures per team, right? This one for line, I'm going to change the line color here to a darker gray, and then reduce the size of the line under the size area here. So we get a little bit better of a line. And for all on label, and then what we'll do is filter again, because we want to look at the period since 1981. So I'll filter, and I want to go from 1981 to 2012. And then what I can also do here, because of that, is edit the axis. And I want fixed. I want to start it at about 14, because that's where this begins. And so now I have a clear visualization that shows the pitchers per team and strikeouts over this period of time. And in fact, I can even clean this marker up here, this axis up, and say this starts around 5. So why don't we start this actually around 4.0. Okay. And we have a much nicer chart that's easy to read. Okay. And actually, one of the things I can do to make this more readable is I can go here and I can take the year on the label and move that off, because we're doubled. So there you go. That's how you use this this different kind of scatter plot to show times arrow. And one of the questions is, which visualization do you choose? And part of it's going to be, how are you going to be able to present these data sets? Is this going to be a large write-up that you can present? Or is this going to be something that you present as part of a visual presentation where you're moving through? Or is this something that people are going to be able to sort through on their own and play with the data sets? So depending on not only the questions that you're being asked to provide answers for or data for, the next part is also considering your data consumer and how they're going to interact with your visualization. And so for something like this, you may want to use this as a static visualization to show that change. But is this something that's readily understandable for your audience? And if it's not, then this might not be the best of choices, and you might want to use the line chart instead. So the scatter plot may work, but then again, it may not. You may decide to go with something else like this. That may be a little complex, so then the scatter plot may be a better visualization for you. Or in fact, this sort of connected scatter plot may actually be one of the easiest to make your visualization or make your meaning clear. So once again, we've learned some Tableau technique, but once again, what we see, and one of the things that we're learning is, as you make these visualizations, the questions you always start off with are, what are the expectations of the data consumer? Who's asking for the data set? What kind of audience is there? And then how are you presenting these data to your audience? And when you answer these questions, you'll be able to have a better chance of choosing an appropriate visualization. It's also important to choose a visualization that communicates your meaning without hitting your audience over the head with your ability to create beautiful visualizations with a lot of excessive features that can distract from your central point. So we'll keep coming back to these ideas and connecting them together. But